Okay, so the simulation, RHYS link with assist. Let's just go ahead and run the simulation. Okay, so I mean, this is set up. I'm just use this as example. It's gonna be in your sample folder, like everything here in the example validation. You after you install, you can see it right here. And you want to put it more, you can go to RHYS. That's let's just find the base folder RHYS. I'll just maybe we can talk about this later. I'm just gonna open this project. Okay, let me just open the project. Okay, so here it just before you run it, I mean, there is usually several things you want to check. Is the plotting, right? There is a plotting, and you can add plots, go simulator, and there's a plot view. You can add plot, and there are few ways to add plots. Either you can click on the normalization. For example, you want to firstly just increase the number, component number. You want to see the dome pressure, and you can right click on it, bring up the context menu, and go to plot 2, and then you choose which plot it goes to. Now the one is showing here is 21, 22, 23. There are different plot windows. Each plot window has 4 plot view tabs. So starting from the plot window 1, it's showing 1 already right here with tab plot 1, 2, 3, 4 until there's, I don't know, maybe 15 plot windows the maximum you can bring up. So like I said, one way to plot things is just go to click on the normalization and go choose plot 2, and you can say this is actually a new feature Ramon recommended. We don't have this plot picking option from normalization before, and so maybe you can plot to 21. 21 is empty right now. Just plot the pressure, click P, and then plot 21 has, oh, it's not. It's actually not empty. It has the mass flow rate. So I can, I accidentally add pressure and mass flow rate in the same plot. I do want to remove that selected graph. I just click remove. And you notice once I click the legend on the plot, it actually highlights in normalization. It tells you where the plotting is, right? I mean, the plotted variable is. This is the 505. That's the flow rate right here, or the pressure of 180. That's the dome. Okay, so let me just remove that one. Okay, so but I can do maybe 22. Oh, well, that's okay. We don't have to plot anyway. So that's just one way to plot it. The second way to plot things is you can right click on the plot window here, or plot view, and add analysis graph, and it just gives you all the minor edit, and then volume quantities, and maybe velocities, volume velocity, and then after you double click, it shows you all the components on the right side you can pick. And after you pick, you can insert it. Okay. That's the second way to add it. And then the last way to add it is you're probably going to use quite a lot, because you have existing input deck, which contains 203 card, right? The 203 is the plot request card. You can either bring it up right here or use system view, which is a little bit straightforward. System view has plot cards. In my case, I don't have any. But if you have a plot, your existing input deck already has 203 cards, you can just click plot, and it's automatically create the plot windows for you. Okay. So 3 ways to adding the plot. And then the next step before you want to do before running the simulation is probably bring up the heat map. In this case, it's already bring it up. You can see the heat map bar right here. But the way to do it is go to simulator and display variable, and then you bring up this heat map panel. In this heat map panel, you can choose volume quantity, which is actually the heat map, because the volume shape of volume has area, right? You can see the color change. And for example, we choose a y fraction g. And on the right side of this column, that's for, it's not heat map, but it's showing the junction data. For example, I can double click on mass flow, and then that's going to show you, if you zoom in, you can see there's numbers. This is actually 0. It's the initial condition, but it's minus e to the minus 300 something. But Anyway, so two things you show on the heat map. One is the Y fraction heat map to a bar, and then the mass flow rate appears on each junction. Okay. So now you have this heat map set up, you have plotting set up, you are ready to run. So you want to bring up the open panel thing here. The open panel actually gonna gives you the screen. If you run assist already, you probably see that there's information coming out from the screen, right? There's a timestamp of stuff. Let me just go ahead and run it. And then they ask you, you modified it, you want to change it? Yes, I want to change it. So okay, so it's just running. It's pretty quick. But you see the heat map is changing. This display the Y fraction of gas, okay, vapor, and also the number of junctions is being refreshing all the time, right? Just showing the mass flow rate because you displayed it, and then there's a units of pound per seconds. So it's running at the same time, and you see here, it gives you the similar, actually the kind of similar simulation information from running assist. Problem time, DT, error max, current limit, n count, right? How many iterations you've been solving the matrix. But the last part is something you don't see by running assist is the DT reduction cost. This is quite useful because it tells you where at what time, and then where is like 152 and what time, right, is 136 seconds. The n count is 82, has a time step reduced, has been, the time step has been reduced because of quality error. The quality error, usually you have a Y fraction goes up to either below 0 or above 1, because there's a not exactly timing for the truncation. So there could be some quality bigger than 1 or lower than 0, and then that cause a little bit trouble for relapse. So relapse said, okay, I have to reduce time step, and it tells you that quality error time step reduce and mass error time step reduce. Mass error is just because the difference between density between the density difference between the conservation equations and the state equations. And there's a high limits. So if you pass that high limit, relab gonna tell you, okay, so you gotta reduce time step. And error appearance have to do a double iteration. So every time error appear or disappear, you have to do a time step repeating. Okay, it's not repeating, not reducing, just repeating. The double. So all these extrapolations, blah blah. So this is quite useful information for you. Quickly highlight what could be the optimization for your input deck, right? Because if you have a input deck with really low ratio of how to say flow area, and no, the lens flow area, that could be causing a current limit and maybe mass error, all these kind of things. So you can optimize your input normalization, and that's actually where you got some hints from that display. Okay, so we're just finished running of this one. One thing I want to mention, there's 3D view. The 3D view actually, you can see there's just our GUI, 3D GUI, and every time you check input deck, it's gonna display the 3D view for you. Okay, and then well, assist this is assist 3D GUI capability. I just adopted and then displayed in within RHYS. So and then so you got a heat map, you got a plotting, and you have output informations. Once done with simulation, you can it tells you transient terminate, and then you can go ahead click on output file and just take a look at it. That's exactly the same thing. When you run assist, you have output file, you can find more information. You can also check the error. Okay, so that's the simulation part. If you have interactive input deck, which means if you do have system view and you have interactive variable, for example, that pipe could be one of the interactive variable. you can trigger during the run, you can stop and then trigger it and make real-time interaction. Okay, so what you can interact here is everything with a trip in it with boundaries. Okay, trip, boundary, and controls. That's the three things you can do real-time interaction. Okay. And the good part is you can rerun it, and then you just click run and rerun it, and then you can stop it pause it any place you want it, and you can check the details. And then sometimes people don't want to see this display the heat map is, and it just you can hide heat map, and it gives you the numbers. You can also, I mean, display data or not displaying data. It depends. If you want to see the data, you can just display data. It tells you real time when you run it. It's gonna change the real time data here. Okay. Uh, think that's actually how you run a simulation.